Dead Men Tales is brought to you by SupplyHouse.com, home to over 180,000 plumbing, heating, and HVAC supplies. SupplyHouse.com launched their official app for pros on the go, bringing everything you need right to your fingertips. This fast shopping experience offers the ability to manage safe carts, scan barcodes, and quickly reorder products. Download the SupplyHouse.com app today on any Apple or Android phone for fast shopping on the go. From HeatingHelp.com, it's Dead Men Tales. I'm Dan Holohan. John Mills was one of the great-granddaddies of hydronic heating. Many knew him as the Great Experimenter. He worked with the H.B. Smith Company as a freelance inventor and engineer from 1873 until 1897. He was forever experimenting with heating and sharing what he knew. In 1890, he published a 2-volume book titled Heat: Science and Philosophy of its Production and Application to the Warming and Ventilating of Buildings. It was one of the first serious books about heating, and this magnum opus became an important resource for boiler and steam engineers in the years that followed. John Mills invented the boiler that bears his name, and Mestec, the successor company to H.B. Smith, made the Mills boiler for many years. He was one of the first to come up with the idea that in a tall building, which was to have a one-pipe steam system, it would be best for the supply main to go straight from the boiler up to the top of the building, and then turn horizontally to go around the perimeter of the attic, and then finally downfeed all the radiators so that the steam and condensate traveled in the same direction. They called this the Mills system, and it worked beautifully, and it still does in many of our older cities. I remember once visiting a fancy building on Central Park West in Manhattan where I saw a Mills system that had 12-inch screwed pipe. It was something to marvel at because a 12-inch screwed T is a lot bigger and heavier than you think. I thought about John Mills that day and about the men who installed that big pipe to his design. I tried to imagine what sort of wrenches those guys owned, where they stood to get the leverage they needed, and what big arms they must have had. Those guys left sweaty echoes in that building, and I could hear them. John Mills also experimented with heat loss, and he developed a quick method for figuring out the load in a building. The industry called it, not surprisingly, the Mills rule. Contractors loved the Mills rule because it was so easy to use. Before long, they nicknamed it the 2-20-200 rule, and I'll explain why in a minute. Most of these size-it-quickly rules of thumb that followed John Mills' rule evolved from this method. They were all fine for their time, I suppose, but not so good nowadays because we build better buildings than they did back in the day. Here, consider what sort of windows they used during John Mills' era. Most likely they were double-hung windows with leaky sashes. And what about insulation? Do you think they used bats of fiberglass back in the day? Do you think they used anything at all inside those walls? Not from what I've seen, and not from what I've read. The heat loss of a building was much greater back then, and the Mills 2-20-200 rule was appropriate for that sort of construction. Not so good nowadays. Here's what I mean. Take any building and size a new steam boiler using the Mills rule. The first thing you're going to do is to measure the square footage of all the glass in the building. Once you have that number, divide it by 2. That's the 2 in the 2-20-200 nickname for the Mills rule. Okay, now set that aside for a moment. Next, measure all the cold surfaces in the building. A cold surface is any wall, floor, or ceiling that doesn't have heat on its other side. In a 2-story house, the first floor walls are cold surfaces if they face outdoors. It's warm on one side of those walls and cold on the other side. If a wall faces another heated room, you wouldn't measure that wall for heat loss. You'd probably measure the ceiling on the second floor of this building because that ceiling faces the attic space, which is unheated. But you wouldn't measure the ceiling on the first floor of that building because that surface faces the heated second floor. The same goes for the floor. You'd count it if it was over a cold crawl space or an unheated basement, but not if it was over a heated basement. Make sense? Good. Okay, once you've measured all the cold surfaces, divide that number by 20. That's the second number in the 2-20-200 nickname. Put it on the back burner with the other one for a minute. We got one more measurement to make, and this has to do with the air that's inside the building. The air is constantly changing because of infiltration. Old buildings were drafty, many of them still are, So let's measure the cubic feet of air by multiplying the length times the height times the width of each room. Now add those numbers together and divide the total by 200. That's the third number in the 220-200 nickname of the Mills rule. So we've measured the window glass, the cold wall, floor, and ceiling surfaces, and the volume of air. The grand total you come up with will be the required square footage of equivalent direct radiation, or EDR for short. 1 square foot of EDR for steam will give out 240 BTUs per hour when there is 70-degree air on the outside of the radiator and 215-degree steam on the inside of the radiator. That temperature of the steam is significant because 215-degree steam is steam at about 1 psi pressure. So what the definition of EDR is telling us is that you don't need pressure greater than 1 psi inside the radiator, even on the coldest day of the year. For hot water heat, when the average water temperature is 170 degrees Fahrenheit, the value of EDR drops to 150 per hour per square foot. This is because hot water isn't as hot as steam. The dead men used the Mills rule for both steam and hot water systems, so keep that in mind. But here's the problem with the Mills rule. We've upgraded the windows and even the insulation in many of those older buildings. The radiators are now oversized based on the current heat loss of the renovated building, and that can cause money to flow out through those new windows if people are going to be cracking them open so that they can be comfortable. If you use the Mills rule or a similar shortcut to figure the radiation for a modern building, you'd probably wind up with enough radiation to heat 3 buildings. That's the problem with using sizing shortcuts in the 1800s. They haven't kept up with the times, and I think John Mills would agree, were he around today. He'd be using a computer to size his systems. He'd probably also be writing the software. Here's a footnote on Mr. Mills. Sometime in 1906, and this was in Westfield, Massachusetts, Mr. Mills wandered into town, dressed shabbily and looking penniless. J.R. Reed, who ran the H.B. Smith Company in those days, saw him and said, "John Mills, I always warned you of this. Didn't I say that if you kept on at the rate you were going with these experiments that you would surely scratch a poor man's pants?" He then gave Mr. Mills a check for $5,000 and said, "You are not going to give this money away or use it for any more experimenting." John H. Mills never again appeared in Westfield, Massachusetts. He died in 1908, and he probably never did stop experimenting. So think of him the next time you're doing a heat loss calculation or looking at an old steam system. He was among the first to see the need for all this. Well, I hope you enjoyed this story, and if you did, please share it with your friends, and please subscribe to this podcast if you haven't already. I have many more Dead Men Tales to share with you, and I appreciate you taking the time to listen. It means a lot. Thanks.